The presentation is entitled Application of Membranes. It will be presented by Susana Fonseca and Jorge Grandão Lopes. I will say now a few words about the presenters. Susana Cabral Fonseca is a research officer at LENEC, the Portuguese National Laboratory for Civil Engineering. She holds a PhD degree in Polymer Science and Engineering by the University of Minho. She works in the Organic Materials Unit of the Materials Department of LENEC, and she has experience on the evaluation of performance and durability of polymer-based construction materials. Jorge Grandão Lopes is also a researcher at LENEC. He is the head of the Buildings Department of LENEC, and he has a vast experience on buildings components, focusing in particular the field of water tightness performance of building envelope and associated pathology. Susana, the floor is yours. You may begin whenever you're ready.
Thank you very much. My name is Susana Cabral Fonseca, and I will present another protection method, the surface protection method, application of membranes. This work was performed by me and my colleagues Jorge Grandão Lopes and Maria Paula Rodrigues. Membranes are used as a concrete surface protection method that leaves a protection layer. The application of membranes as a concrete surface protection method could be understood as a means to create a barrier on the surfaces to meet one or a combination of the following requirements: the protection against ingress of moisture, water, chloride ions, and other contaminants into the concrete, improvement of the resistance to other deleterious influences like chemical substances, increase of the surface resistance against abrasion or impact. We have essentially two types of systems, the waterproofing and the protective. The first one is used where concrete structures are designed and built to contain water within the structure, such as swimming pools or water reservoirs, or to maintain dry conditions within it when subjected to wet conditions on the outside, as happens in roofs or in bridge decks. The second type of system is the protective ones that use in concrete structures that may be subject to chemical attack. Waterproofing systems are used as a barrier to prevent the ingress of liquid water under or in absence of hydrostatic pressure. Examples of these applications are foundations, floor slabs, roofs, traffic and bridge decks, and swimming pools. The protective systems are used to protect concrete from degradation by chemicals or to protect liquids from being contaminated by concrete, as we have in the example of water treatment facilities or in chemical industry. We are talking in our presentation about the most important type of membranes, the liquid to apply membranes that I am showing you, and the prefabricated membranes that my colleague Jorge Grandão Lopes will show you after me. So let's move on to the liquid applied membranes. So liquid applied membranes are applied on site in a liquid form and can be water or solvent based. Liquid membranes can be applied in a single or two component system, the reactive systems, and with or without heating. Sometimes, for special applications, it is necessary to build a multi-layer membrane with a sequence of different products. The techniques used to liquid apply membranes are usually brush, roller, squeegee, and spray. As with most coating application, surface preparation of the substrate is one of the most important steps to ensure a good and long-term performance. The application equipment and the skills for different liquid applied membranes are quite different and sometimes complex. And for this reason, the technical staff must be trained in all involved operation. In addition, the regular equipment maintenance and cleanliness are vital. Protection system with membranes should be designed by a specialist, and this is very important because he needs to demonstrate that he has a suitable level of knowledge on the products, the systems, and on the selection of the particular solution for each case. Designers should always use normative references and existing code of practice in their project specification. This is also true for the prefabricated membranes. Have a specialist in the design and the specifications for the particular case. The selection of the appropriate solution for a specific project involving liquid applied membrane should take into account three types of aspects. The first one is the installation requirements. It's important to have a clean, dry, and sound concrete surfaces. We need to choose which type of techniques, spray brush, ruled, or squeegee. Control the ambient conditions and have availability of skilled and experienced applicators. In terms of the membranes itself, their performance in some very important properties needs to have to take into account. So, I will show you that the importance of water and vapor permeability, in particular for the waterproofing systems, but also the crack bridging properties, the bound resistance to the substrate, skid and slit resistance if necessary, and appearance if relevant. And the durability is very important in some circumstances. Have knowledge about the chemical resistance or the abrasion resistance, and for outdoor applications, the ultraviolet resistance. The execution starts always with the preparation work. It's very important to have a surface preparation, as I have already said, and this surface preparation must be done according to the protective system selected. For liquid applied membranes, the concrete surface should be relatively smooth because most products are not intended to develop or white the imperfections of the substrate. For many projects, it will be necessary to prove the membrane being applied in a site trial in order to certify its compliance to the specifications and to the requirements requested by the designer. This is particularly true where the performance of a new type of membrane or system must be proven. In the execution procedure, there are three types of problems that can affect the performance of the membrane systems applied in liquid form. Deplication factors such as poor mixing of the components or mixing of components in inappropriate temperatures, or incorrect proportioning of the components, or delay in application of the mixed components. Another problem that can arise from the substrate conditions. So if there are moisture in the substrate and if there are a poor surface preparation or inadequate preparation of the surface. And the ambient weather condition. In fact, particularly in outdoor application, the speed of the air, variation in air temperature, relative humidity, and the presence of rain could affect the performance of the membrane that are applying in this liquid form. A quality assurance system should be proposed in the design specification and must be implemented before, during, and after the membrane application. And the properties of the substrate, the acceptance of the products, and the conditions for their application shall be subjected to quality control. In the case of the materials, all the relevant physical and mechanical characteristics should be provided and should fulfill the minimum required performance. The type of membranes depend on the severity and aggressiveness of the environment, and the selection must be based sometimes on testing or in past experience. Before the intervention, a quality control for the preparatory work must be implemented, and the air temperature, humidity, and substrate temperature should be monitored before the membrane application. During the intervention, the quality control usually includes visual examination of the surface during and after the application, control of consumption, wet layer thickness measurement, dry thickness measurement in a test panel usually, testing of adhesion to the substrate, sometimes in a site trial panel, and the documentation of the work based on established protocols, for example, taking photos or filling checklists. After the intervention, an inspect and maintenance plan should be implemented, indicating the periodicity and type of actions to be performed. Periodical inspection should be reported and any eventual deterioration should be evaluated. The concrete protection with membranes require regular maintenance, and the type and the frequency of maintenance required are directly related to the types of deterioration problems involved and depends on the system and conditions of use. And this is also true for the prefabricated membranes that we will present in the next part of this presentation by Jorge Grandão Lopes. Thank you.
Hello, good morning, everybody. Again, thank you, Susana, to give me the floor. As Susana said, my presentation will deal with the prefabricated membranes as waterproofing systems of several types of construction of concrete, as building roofs, floors, and walls below ground structures, foundations, bridge deck, water reservoir, canals, and others. Prefabricated membranes are membranes applied as sheets or rolls. The most common prefabricated membranes, at least in Portugal, and as I suppose in most European countries, are made of modified bitumen with styrene, butadiene styrene, known as SBS, SBS, or atatic polypropylene, APP. Of course, there are still applications with traditional membranes using oxidized coats. The other types of prefabricated membranes are thermoplastics, as polyvinyl chloride, PVC, and synthetic rubber, as ethylene, propylene, diene, methylene, EPDM, or butyl rubber. The techniques of application of membranes, prefabricated membranes, are the following: fully bonded, partially bonded, loose lead, or mechanically fixed. The prefabricated membranes using bituminous membranes are generally put on place fully adhered or partially bonded to the concrete substrate, using usually previously a primer on concrete to improve the adhesion of membrane. These membranes are bonded by heating using a hand or a machine torch flame gun, as you see in the photos, the first photos. Some prefabricated membranes include a self-adhesive backing on the sheet. These sheets are rolled on place and then bonding using a roller. The prefabricated membranes can also be applied with appropriate glue. In some countries, it is forbidden the use of flame gun for reasons of fire risk. All these techniques are used also to bond the lap joints of the membrane. For thermoplastic membranes, the joint bonding techniques consist on the use of hot air, guns, or solvent-based glue. The loose lead techniques consist simply of unrolled membrane over the substrate. In this case, of course, you need a heavy protection layer over the membrane to avoid its uplifting due to the action of the wind. The mechanically fixed systems is an interesting system for the rehabilitation situation, especially on roof, building roofs. Consists on the application of screws and washer conveniently spaced on overlap joints or on their current surface. Certainly that the use of each technique depends on the type of the construction elements where it will be applied. Concerning the design, I will highlight some aspects for some field of application of the membranes. Of course, there are some consideration made by Susana applicable to the prefabricated membrane, so I don't repeat that considerations. For roofs, it is important, for instance, to take in consideration the accessibility of roofs, roofs used only for maintenance, roof accessible to person or to vehicles, or roof gardens. So it depends of this type of roofs, the consideration concerning the design of the layers of the roof, and also the type and the position of thermal insulation. On roofs, you have a warm roof or the inverted roof. The waterproofing in the inverted roof is below the thermal insulation. And of course, you have to take into account the ease of maintenance in design. For bridge deck or other traffical areas, it could be mentioned the mechanical resistance of the system, namely against the braking effects, and the compatibility of asphalt layer generally used on road bridge. For walls below ground structures, the mechanical impact of the soil when filling ditches, of course, a protection layer is necessary. You can see it in the figures below, and the effects of roots from trees next to the building. Two examples to be taken in account on the design of these systems. Related to the execution, I will highlight some aspects concerning the execution of prefabricated membranes. Ensuring the width of the membrane overlap joints across all the surface of the concrete elements is, of course, an important aspect in the execution of the waterproofing system and of their performance during the lifetime. For the adhered waterproofing systems or fully bonded systems, the cleaning and the level of humidity of substrate are another important parameters to be taken into account. Using torch flame gun, melt the bitumen of the membrane to the support, the temperature of the flame, the distance from the gun to the membrane, and the speed of the gun are the three most important aspects to be considered. The constancy of these parameters on the entire surface of the building element must be ensured. So the workmanship is an important issue, of course. And a very important aspect to be taken in consideration is the quality of details executions. These singular points are generally the origin of leakage due to lack of design or the difficulty in the execution. Concerning the quality control, I give you just an idea about some characteristics of membranes, prefabricated membranes for the field of application referred. This characteristic may have implications for the occurrence of anomalies that compromise the water tightness or the water vapor permeability of the membranes. These common characteristics are well known, the thickness of the mass per unit area, the tensile strength and elongation, the tear strength is an important characteristic for the application, the static loading and dynamic impact, and the dimensional stability. There are another specific characteristics applicable only to one type of each membrane, as the flow of the bitumen coat at elevated temperature for bitumen membranes, of course, or the plasticizer content for the PVC membranes. The requirements of each characteristics are defined in normative standards or similar documents. A preliminary and rudimentary quality control on the reception of membranes on place can be easily achievable for some characteristics without the need of using a test laboratory. We are talking about against ourselves. As for example, it is easy to identify a bituminous membrane reinforced with a current fiberglass felt from another one with polyester felt. For instance, the membrane reinforced with a current fiberglass felt will be more easily teared by hand than the membrane with polyester felt. For sure, you need a lab to check and determine the exact values of these characteristics to compare to the design specification. On site, it is also important to have some procedures to evaluate the quality of work done for this type of membranes. I give you some only example. It is well known the techniques of checking the overlap joints of PVC, the quality of overlap joints of PVC membranes on roofing, using a tip that slides over the edge of these joints until it finds some unglued zone. So it is a very simple procedures to detect a not glued zone of the overlap. So that is what I have to say about this matter in the time I have disponible, and I have disponible, of course, to the question that you have. Thank you very much for your attention.
Thank you very much, Susana and Jorge, for your very interesting presentation. Well, I'm happy to say that we have one question. Gassin Ahem, one of the attendees, is raising, in fact, a double question. Is asking, I think it is for Jorge Grandão Lopes, if you can give some advices regarding double bitumen membranes and if they are recommended. And also he asks if it is possible to fix tiles on these membranes, for instance, on accessible terraces.
Okay, if I understand well the questions concerning the first one, the use of double bitumen membranes, I suppose you are talking about the using of two prefabricated membranes of bitumen membranes. Okay, it is preferable. It is preferable to have two membranes than one, of course, to guarantee the water tightness of the structures. It depends of the characteristic of each membrane. Let's give an example. For example, for roofs or for bridge decks, if you have a membrane reinforced with polyester felt, generally more strange than fiber felt, as I said before. So, and if you have the person that applied the membranes know very well the techniques and they have experience of application of this type of membranes. There are, so we can use one membrane if the joint is well done all over the surface. The thickness of the membrane at least 4 millimeters, 5 millimeters for the roof. For a bridge deck, 5 millimeters. I suggest this thickness. and of course with a reinforced polyester reinforced inside the membrane. Generally 120 grams per square meter is a normal polyester felt or more. Okay, so if you have a membrane with if you want to put just one membrane reinforced with glass fiber with 60 grams per square meters, the normal one. So I suggest even the accessible of the roof is only for maintenance. I suggest at least I suggest two membranes with APP or SBS membranes. It's different if you talk about oxidized membranes, traditional membranes. In this case, the majority of guidelines or recommendations in Europe is to put at least 3 membranes with the mass, the total mass of the bitumen, 10 kilos per square meters. So is the recommendation all over Europe, at least as I know. But it's not these traditional membranes are not too much used, so I don't want to talk too much about this.
Okay, thank you. The second part was about replacing or correcting some tiles that are applied on top of these membranes. Is that possible?
The tiles, which type of tiles? So we have to replace, I suppose you are talking tiles for roofs, of course, maybe it's for roofs.
You refer to accessible terraces and that kind of
yeah. So for flat roof, of course, it is not a good idea. But for pitched roofs, we can use also these prefabricated membranes, and we can use tiles, of course. We can replace tiles by prefabricated membranes, or the inverse, if it is possible. So it's and we can use both. Okay, you can use prefabricated membranes as a complementary of the water tightness of the roof, of the pitched roof, if the slope of the pitched roof are low, the slope is low. So using tiles, for example, ceramic tiles or stone tiles, depends, or wood tiles, if the slopes are low, below some values, we can complement the water tightness of the joints of the tiles with a membrane, a prefabricated membrane.
Okay, thank you. There are 2 other questions and we still have time. Hamid Reza Motlak is asking, from your point of view, what type of protection is more suitable for concrete slabs on bridges? So he's referring to bridge decks, and mainly considering resistance to failure simultaneously with heat and cold weather, and also the application of the pavement, asphaltic pavement. And then I will raise the last one perhaps after you answer.
Maybe the question is for me too, no? No.
Yes, you
Also,
can both open also please the Q&A window, and you can read also the question. I think it is also for you, the question. Yes.
Yeah. Okay, the protection for bridge decks. So
and the problem regarding heat.
Yes.
cold.
So on bridge, if you are talking about roof, I have the answer very nice. For bridge decks, of course, you don't put thermal insulation over the membranes. So you have the normal protection of the membranes, the asphalt layer or concrete or bricks, stones, aggregates, and so on. So, but we have to have a protection concerning the function action of the if you have concerning the railway bridge decks, for instance, you have stones. No, I don't know the correct name, but you have stones is a normal protection that we have. So below these gravels, you have normally a concrete or a mortar protection, and below you have the membranes, the prefabricated membranes. So the temperature, cold or warm temperature, affect naturally the membrane. So you have to choose, in this case, we have to choose a membrane that have good resistance to the flow and good resistance to cold temperature. And you have a good membranes, bitumen or PVC, that are resistant to minus 20 degrees and over 100 degrees. So it is not a problem to choose a good membranes concerning this atmospheric action. Okay.
Okay, thank you. And the last question, well, in fact, it was raised by Eduardo Cavaco. He says he can't use the Q&A button. Perhaps we are not allowed for being co-hosts. But the question is precisely about a comparison regarding the lifetime of those two membranes, bitumen membrane or versus the PVC membranes.
Yes, is the typical question. Thank you, thank you for the question, but the answer is not easy. We cannot talking about the durability of one membrane. We have to talk about the systems. Let's give a simple example also. If you have a membrane, the same membrane on roof with the thermal insulation over the membrane, is totally different if you have the membrane over the thermal insulation. The standardization and documents related to this type of membranes define. You have to have a criteria, of course, to make the tests and to compare the solutions, to compare the membranes in this case. The minimum durability or the criterion that you use to evaluate each product, each membrane, is 10 years. Of course, the membranes have a durability much more. They have to have a durability much more than 10 years. And I saw membranes, traditional membranes in Lisbon, for instance, with 30 years old or more, without leakage yet. So it's what I can to say about this. If I have a system, a complete system for bridge deck or roofs and so on, so I can give an idea. This is more, it is more durable in principle than the other one systems, not only the membrane. Okay. Thank you for the question.
Well, thank you very much for your answers.